Okay. All right. Okay, so we are live for this particular section, and this is a continuation of our solution of the exercises of 201, and in this section we are continuing with module 2, and that is question 4. Okay, so we are continuing with question 4, right? Recall that we have done all of module 1, module 2, 1 to 3, so we are continuing with module 4. Okay, so let's go. Question 4. So what is the question saying? Okay, the first part of the question says, that's A. Okay, A says that by inspection, that is without computing, we should show that the determinant of matrix A is equal to 0, where where our matrix A is equal to this. We are given B plus C, C plus A, and B plus A, while here is A, B, and C, and then here is 1, 1, 1. Okay, so this is what we are given, and then we are to show that the determinant of this without computation is going to be equal to 0. Okay, so one of the things that you are going to notice here, now what they're actually trying to do here is to let you observe, that's by inspection, that this will be equal to 0, meaning if it were an objective question, with that observation you may not necessarily need to compute this. Okay, so and how do you do that? So of course, one of the things you can use is to note that by row reduction of this matrix, you are going to get that this second row is going to turn to 0. What do I mean? You know, by row reduction, I would need to do something like root 2. In order to make this a to be 0, I will do root 2. Maybe I will use the coefficient of this to multiply root 2, so which means something like b plus c times root 2, then minus a times root 1, so that I'll be able to get 0 under this first row here. So, and if I do this, you discover that everything here is going to turn to 0, and so the determinant will definitely now lead you to 0. But then another one you can use is that they even gave it in the observation. They said that you should observe that 1 times row 2, that's in the hint, that 1 times row 2 plus row 1 makes row 1 identical terms, right? So that means if you do something like 1 times row 2, which means row 2 plus row 1, so you will discover that what you will get if you use this to replace row 2, you are going to get that row 2 will become the same. That's in other words, what you're actually doing is this plus this, this plus this plus this. You are using it to replace row 2. So you are saying that this should become your row 2. So, and if you do that, you will see that all of row 2 will be similar. And then if all of row 2 becomes similar, see what we're going to have. Let me quickly show you. So it's going to be something of this nature. You're going to have b plus c, then c plus a, then b plus a, and then here will be a plus b plus c. That's if I add this to this. And then this one will also be a plus b plus c. And finally, you are going to have here a plus b plus c as well. And here is 1, 1, 1. So you see row 2 will become the same, all true. And once that happens, you know that whenever you're given a matrix like this, you are allowed to cancel out if there is any. That's to multiply through by a common factor on a particular row. So I can actually multiply this row by, or I can say divide the row, divide row 2 by that common factor, okay, which is a plus b plus c. And if I do that, I am now going to obtain that my matrix A is equal to, okay, so you are going to have something of this nature as your matrix A, which is b plus c and c plus a, and then a plus b, and here is going to be 1, 1, 1, then 1, 1, 1 as well. Okay, so, and if you take the determinant of this, of course, by the time you take this one and then cross here and here into the bracket, remember to do the determinant, we need to get the adjoint of these first terms. Sorry, we need to get the cofactors of these first terms. Okay, so in order to do that, so you would have to pick this and then cross these two and then multiply this minus this one. Okay, so which is going to give you 0 at that point. So, and when you do it for all of them, you will still get 0, 0 all true. So meaning that the determinant of A will be 0. All right, so all you need to do here is to let us know that of course, yeah, you can actually write this way if you care. Otherwise, you can just let us know that after the hint that was given there, we are going to produce this, okay? And then after producing that if we divide row 2 by the same term, that we're going to have 1 all true, and that means that the determinant of this is going to be 0. All right. So, haven't seen that. That is all for A part. So we go over to question B of the same number 4. And there it says that we should write the general solution of the equation. And this is the equation you are given. 10x minus 3y and then minus 2z equal to 7. They say we should write it in parametric vector form. In parametric vector form. Okay, that's the solution in parametric vector form. You know, you can actually write this solution in just a parametric form, so without bothering putting it into vector form, but here they are asking us to do it in parametric vector form. So what do we do exactly? Let's see. So here we are going to have that of course the solution. First of all, you're going to observe that whenever you want to get parametric vector or parametric form or solution, all you need to do is to give a name to the free variables, or you can just leave the free variables with their normal name, but then make the leading variable the subject. Okay, so from here we have 10x minus 3y minus 2z equal to 7. So which ones are the free variables? Here you can see z and y are free variables because this is just one equation. Assuming there are two equations here, then you have something y and then z here equal to something, then you can say you have two leading variables and then only z will be the free variable. But since this is just one equation, so y and z are free variables, so that means their values, whenever you are talking about free variables, it implies that their values are fixed. So y is equal to y and then z is equal to z. Okay, so now if that is the case, then all I now need to do is to now make x the subject. So I'm going to have 10x So I'm going to have that 10x is equal to, of course, here is going to be 3y and then plus 2z. Okay, sorry, remember we had, sorry about that break I had. Okay, so remember we had 7 here, so we put our 7 plus 3y then plus 2z. Okay, so and that is what we have. All right, for the first one. Okay, that's for the value of 10x, and then we need to get x in particular. So to get our x, we can divide through by 10, so which is going to give us that x alone is equal to 7 over 10. That's your dividing through by 10, then plus 3 over 10y, then plus 2 over 10, which is 1 over 5z. Okay, so having gotten this, what you're going to now have is that you already have the value for your x now. So you are now going to form the, you have the value for your x, y, and z. My y is y, my z is z, because they are free variables, so I fix them. Okay, so now I'm now going to form the solution. The solution is x, y, that's the solution vector, is x, y, and z. And what did I get as my x? 7 plus 3y plus 2z. Okay, and what did I get as my y? My y is y. And what did I get as my z? My z is z. Okay, so you can close that. So that's the solution vector. But to put it in a parametric form, then you will need to separate the variables that are involved. Okay, so and you can see here we have three different categories. We have all constants, so that means the first one here is going to be 7, 0, 0. That's all constants. Then the second one plus is now going to be the coefficient of y. That means 3, 1. That's in the second row, the coefficient is 1, and in the third row is 0. Okay, you know how I got 0, 0 here? That's the constants in the second row and third row. And then finally, I will now have the coefficients of z, which is 2 in the second row 0, and in the third row 1. Okay, so sorry, meanwhile here you are supposed to have that y will be multiplying this one. Okay, then in the last part you will now have something like the coefficient of z, which will include 2, 0 and 1. So we have 2, 0, 1. Okay, and that is multiplied by z. Okay, and so you have produced the solution in a parametric vector form. So here you can now choose to give values or names to what you have here. So of course this one is going to be a plane. So why this one is going to be the two vectors, all of this will span that particular vector, of course, produce all the possible solutions of that vector. That's actually what we are saying. Okay, so, and of course we can stop here. So that is exactly what you are required to do. Okay, so now we move on to the next question, which is C. All right, so for C we are told that we are given that let me write that ABC, matrix ABCD, DEF, then we have GHI, okay, is equal to, okay, sorry, what we had there was is the determinant. Okay, sorry about that. The determinant of this, let me use this. So the determinant of this is equal to something, let me remove here. Okay, so we are given that the determinant of that matrix there is equal to minus 10, and then we are asked to find the determinant of this other one. Okay, so let me write. So we are asked to find the determinant of this. Let me draw this, then write it. Okay, so the values there are minus 3a, then we have minus 3b, then minus 3c, we have d here, and we have e, we have f, we have g, minus 4d, then we have h minus 4e, then we have I minus 4F. Okay, so what are we going to do there? That's a little tricky. Okay, so we will try as much as possible to see how we can transform this matrix to contain this other matrix, because we know that there's a relationship between a constant coefficient and of a matrix and the magnitude, or the, what do you call it, the absolute value of a matrix. Okay, so which is the determinant. So what do we do? Like I said, we'll try to see, is it possible to write this to be something that will contain this other matrix. Okay, first of all, you can see that minus 3 is a multiple of the first leading the first terms here. Okay, so minus 3 is a multiple of that. So what do you think is possible here? Okay, so let's see what we can do there. If I bring out that minus 3 up there, how is it going to look? How is it going to look? Okay, first of all, let's see something. Let's assume we want to get the magnitude of this. That's the determinant. So remember, this is plus, minus, plus. So you pick out the first one, minus 3a, into the bracket of, it will multiply this one, which is here you will have E minus the product of this, and if minus multiplies this, that's going to be minus I plus 4F. Okay, then minus this will become plus, so we'll have plus 3b into the bracket of right, we cancel here and here, so this will multiply this, which will give you di minus 4. What did I multiply in the first place? This was supposed to multiply this and subtract this. Sorry, I didn't do that well. Okay, sorry about that. Okay, so this was actually supposed to be, let me remove this also. So this was supposed to be E times this, which is EI minus 4EF. Okay, then minus this times this, which is minus HF. Then this times this will be, remember there is already existing minus here, so that minus will multiply this other minus to give us plus, so which is going to become plus 4EF. Okay, all right, so that's for the first part. So for this one is going to be plus, let me use another distance, so it will be plus 3b multiplying, now we cancel this and this, so this will multiply this to give us di, and then this would multiply this to give us minus 4df. Okay, so we now have minus, the same thing will happen, this will multiply this to give minus gf, and if that minus f multiplies this, it will be plus 4df. Okay, close that bracket. Then we now have minus 3c. Okay, because plus minus is minus, minus 3c into, of course you cancel here and here, so this will multiply this to give you df. We have df there, sorry, dh, not f, so dh, so we have dh here, and then this will multiply minus 4e. Excuse me. Okay, so this will multiply minus 4e to give us minus 4de. Okay, and then minus, so minus e times this will be minus ge, and minus e times this will be minus plus 4de. All right, so we are done with that. So from there, even though, like I wanted to say, there is actually a way we would have done this and it would have given us what we wanted straight up. So but let's go ahead and see what this is going to be, and then we can come back to it and I'll show us. All right, so what's going to happen here, if we open up this, meanwhile let's come back here a little bit. This one now, the determinant here is actually a into ei minus hf, then minus b into di minus gf, then plus c into dh minus eg or ge. Okay, so that's actually what gave that 10 minus 10, this one we have here. So in other words, this is going to be, okay, if you open this, just have this at the back of your mind while we come back here. All right, so now let's try to see if we can open up this bracket and check if things can cancel out. Let me move this my equal sign a little bit, so to this point, so I can have minus 3aei, then plus 12a then plus 3AHF, then what again, minus 12AEF. Okay, so you can see this and this are the same, so this will take away this, and so we have only these two left. All right, so let's go again. So we are now opening this one, plus 3BDI, then minus 12D, B should come first, 12BDF, then this one minus 3BGF. Okay, let's come down, and then lastly this will be 12 plus 12 BDF. Okay, is there anything common? Yet again you can see 12 BDF will go away. So the last one, which is this, you have minus 3 CDH plus 12 CDE, then plus 3 CGE or GCE, anyone, and then finally minus 12 CDE. Okay, and again you can see that this cancelled out this. Right, so from here we just have, what do we have left here, which is minus 3 AEI plus 3 AHF, then plus 3 again BDI, then minus 3 again BGF, and then here we now have minus 3 CDH, and finally plus 3 CGE. Okay, or GCE, anyone. Okay, or CGE. All right, so you can see we have about 6 terms here, which will correspond to the number of terms we have here, which are also 6 if you open up this. Okay, so let's try opening up this one, so you see what will happen here. This one is going to be AEI minus AHF minus BDI plus plus what now, plus BGF, then plus CDH minus CGE. Okay, so come back again to where we were here. You will just see that what we have here down here is just a multiple of what I just did up there. Let me see if I can bring down that guy here. But before doing that, let me first of all factorize. Let's bring out minus 3 here. If we bring out minus 3, see what is going to be left here. AEI minus AHF plus, minus again. Here will be minus BDI. Then this one will be plus BGF. This one will be minus, plus, because you're bringing out minus. So this will be plus CDH, while this one will be minus CGE. All right, so let's try to bring down that value we got as this one now, as the determinant of this. Let's try to see if we can bring it down. Let me see. Okay, here we have okay, so did I copy it well? All right, I wanted to copy it, but now it's going to carry everything, no problem, since we just needed it for something here. Okay, oh no, all right, no problem. So let's just use it here. Okay, or maybe I can reduce this board, and that will allow us see the two of them at once. Okay, yeah, yeah, let me remove this now. So see what, okay, see what we had here, this, or what we have here, this and this. So remember that this is equal to this minus 10 here. And now, so you can see the similarities. This is exactly equal to this. This one is equal to this. This is equal to this. This is equal to this. This one, the same here. This one, sorry, I forgot to write my E here. And this one is equal to this. So we completely have the same value we got here in the bracket. And that is all we needed. Like I told you, you would see that immediately what the magnitude of this one they asked us to find here is going to just be equal to minus 3 times the magnitude of the one they gave us, which is 10. And that is equal to, sorry, minus 10. And that will give us what? 30 as the solution. Okay, so if we want to use this approach, all you need to do is just first of all try to get the value of this in this form and then equate it to 10. So when you get this, so you imply that this is equal to minus 10, not 10. And then you can keep it as maybe equation 1. And then you will do this other one and you will get to this point. And then you will substitute equation 1 into this place. And that will give you your solution as 30. Or otherwise, you can just state for us that this particular one we have here, that the determinant is just equal to minus 3 times the determinant of the one that is given. But you would need to state the condition that made that possible. So you can just use this approach instead of putting yourself into that squabbles. All right, so let's go on. We go over to the next one. And the next one is question D. Okay, so there we are told to consider. I like these exercises in this manual. They are demanding. You know, they allow you to think. And especially this one we just did now. I'm going to do, you know, a single video on that. It's very beautiful. It says, consider the matrices. And what are the matrices there? We have A equal to, so for A we are giving 2, 1, 2, then 2, 2 minus 2, then 3, 1, 1, if I'm correct. Okay, and then we are giving X to be equal to X1, X2, and X3. Okay, and we are asked to show that, okay, we are asked to show that AX, the equation, show that the equation AX is equal to X can be written as A minus this, that, blah, blah, blah. Okay, the X here, I believe, should be this capital X. Okay, equal to this other X can be written as I'm writing the question. All right, so this is the question that we are given here in D. So we are to show that if we have matrix A, B, A, and then X, okay, that we can write equation ax equal to x to be of this form. All right, and how was that achieved? Of course, if you have ax, even by observation and the small mathematical understanding that we have, even though that most times it doesn't hold for matrices, so you must be very careful. So if I have ax equal to x, with small maths you can do something like this. Ax, this one come over, you will get minus x equal to 0, and that's going to give you, if you factorize here, you are going to have a minus, of course if I remove, now I'm bringing x out now, so if I bring out x, a will be left here, and then here will be 1, and you know 1 in matrices is the identity matrix, is equal to 0. So, and this is exactly what we have here. So but when they are saying we should show, maybe they want us to use the matrices to do it. So that means it's either we do this or we can bring in the matrices. So let's try to bring in our matrices. Okay, so there we are going to have so there we have something of this nature. We want to show what now, that a minus I multiplied by x is equal to 0. That is equal to 0 matrix. Okay, so by expressing them so. Okay, so let's see. That means they just want us to express. Okay, so let's see. Now this is the same thing as having, now you have your a. Our a is 2, 1, 2, then 2, 2 minus 2, then 3, 1, 1, and then we have minus I, which is the identity matrix, is 1 in, since it's a 3 by 3, so it's going to be 1, 0, 0, 0, 1, 0, then 0, 0, 1. Okay, remember that all of this is multiplying our x, and our x is x1, x2, and x3, and then they are saying we should write this as equal to 0. But first of all, let's get the value. So what's the value going to be? Open up this. So if you open, you are just going to have subtraction. So 2, you are subtracting the corresponding components. 2 minus 1 is 1. 1 minus 0 is 1. Then this one will be 2. And then here you are going to have 2 minus 0 is 2. Then this one is 1. Then this one is minus 2. Okay, so if so that means 3 is going to return, 1 will return, 1 minus 1 will turn to 0. Okay, and you are multiplying this by x1, x2, and x3. Okay, and of course this is going to give us if we open this multiplication, this will multiply this, so we are going to have x1 plus x2 plus 2x3. all right, then of course this will be equal to 0. Remember they said this is equal to 0, and whenever you have 0 in vectors, it actually means the 0 vector. Okay, or a matrices, it means the 0 matrix. Okay, so this is going to be equal to 0, and then the next one you are going to have 2x1 then plus x2 then minus 2x3. What you are having is that this is multiplying this, and of course you know this will multiply this by this, and just like that, and that is equal to 0. And then of course when you bring down this other one, it will go this way, so you have 3x1 plus x2, and then 0 times this is going to give you 0. Okay, so and then everything here is equal to 0, and you can as well put 0x3 as equal to 0. Okay, so that's what we have here. All right, so and that's what they said we should do. You should express this. If it is equal to 0, you should write out the expression, and we have done that. And it's left to know whether if you solve that, whether you are going to get all the values of x1, x2, x3 to be equal to 0. Maybe you can try that. Okay, So, and this is the last question for the last part of question 4. Okay, so we move to question 5. Over to question 5. Okay. I want to know how long this section has lasted. About 40 minutes. Okay, please kindly like the video. Give a like, everyone. All right. So now, okay, so we move over to the next one, so which is question 5, and we're going to do that on a new page. Okay, so question 5, let me bring this up again. I think this is okay. All right, so here we have for question 5, okay, so for question 5, they started with the first question, which is A, and they said that state 5 invertible matrix theorem. You know, okay. I've already used some of these theorems in solving some questions here. So I'm also not going to do all of it for you. So I'm just going to do 3, and I will allow you to find the rest. Okay, you get the point? All right. So okay, so first of all, A is invertible. A is invertible if the determinant, let me not put it that way, if the determinant of A, or let's put it this way instead, if the determinant of A is not equal to 0. So this is invertible matrix theorem. So that tells us that for a matrix to have a determinant that is not 0, then that particular matrix must be invertible. Okay, the next one is that what should I give you now? Which one? Okay, so the next one is that A has okay, if you have let's say if A is an n by n matrix, that means is what do you call it, is a square matrix of n dimension, then we say that A has n pivots, n pivot positions. Okay, so n pivot positions. If it is an n by n matrix, it has n pivot positions. Okay, all right. And then another one is that if I have AX, if AX is equal to 0, that means if a matrix multiplies a vector and is equal to 0, a vector of the same dimension, then that particular AX equal to 0 has only a trivial solution. Then AX has only a trivial solution. Only a trivial solution. Only the trivial solution. Only the trivial solution. Okay? So if AX is equal to 0, then it has only the trivial solution. That's if by reduction you still have equal columns and equal rows. Okay, so you are going to get trivial solutions, or may not be equal columns. Let it just be that the number of equal rows to the number of variables present. Okay, so and all of that. Okay, so you can find many other invertible matrix theorems, but I'm going to stop with these 3. So just complete that. They said you should bring out 5. Okay, so but I will stop there. Okay, so we move over to the next question, which is question B. So B, we are told that we should solve the equation. So you can see in question 5, it appears that we have fully entered into systems of linear equation. Okay, so solve the equation ax equal to 4x for x, given that, okay, so you are solving for x, that's actually what it means, given that our A is equal to, given that our A is this matrix 2, 1, 2, then 2, 2, minus 2. I think this is the matrix we dealt with earlier on, and then 3, 1, 1. Yes, it is. It's the matrix we handled up there. Okay, so but this time around there we are having 4 here. Okay, so all we need to do is to do exactly the same thing we did earlier, and then try to now bring in the equation and then solve it. Okay, so let's try doing that. So first of all, solution. Okay, so what we are going to have is that, of course, this should come over here to give us 0. So we are going to have ax minus 4a should be equal to 0. Sorry, 4x should be equal to 0. And then, of course, just like what we did in that question up, this is going to give you, if you bring out x, you will have that a minus 4i. Remember? Or you can just write 4 if you want. You know, you can just write 4. It's still the same thing. Multiplied by x is equal to 0. But just know that this 4 is actually the 4 of the identity matrix. And so what is this going to produce? So it's going to give us something of this nature. So we are going to have a minus 4. In that case, our a is the normal a we are given, which is 2, 1, 2, if I remember. Let me bring it down. Yeah, 2, 1, 2. Okay, then you have 2, 2 minus 2, then 3, 1, 1. Okay, so here you are subtracting. In this case now, this is a column matrix 4. So 4, 0, 0, and then 0, 4, 0, and then 0, 0, 4. Sorry, diagonal matrix, not column. Diagonal matrix 4. And this is multiplying our x1, x2, and x3. So it's just exactly the same thing we did. And then on the right hand side, you have 0, 0, 0, all true. Okay, so now having seen that, what do you do next? So you will now subtract this and then multiply by this, which is going to give us, in subtraction of this minus this will give us minus 2. I'm talking of corresponding components, then this will remain the same. And then here, 2 will remain the same. 2 minus this is also minus 2. And then minus 2 will remain here. Then this minus this will be 3, 1, and then minus 3. Okay? And that is multiplying our x1, x2, and x3, okay, to be equal to 0, 0, 0. Okay? So forming our equation now, we are going to have, remember how I did it earlier, so this will multiply minus 2x1, just attach x1, x2 to x3 all true. So this will be plus x2, and then here will be plus 2x1, and then this one is going to be equal to, or we can actually do this using row reduction of the matrix. You get? So instead of forming equations, systems of equations, we can just do a row reduction of this particular matrix here. Of course, you know that if this was not a homogeneous equation, remember a homogeneous equation is one where the values on the right hand side are not all zeros. So if it were to be a homogeneous, a non-homogeneous, we'll bring this over and then form an augmented matrix. So but here we are just going to have, I can still use my curve bracket. So we are just going to have minus 2, 1, 2, then 2, minus 2 minus 2, then 3 1 minus 3. Okay, so like what I was saying now is that if this were to be a non-homogeneous matrix, we will now augment this one here before reducing it. Then because it is just 0, even if you put it here, everything will still be 0, so we will not bother doing that. Okay, so we'll start our row reduction. So this is going to give us, first of all, it's always important to have a leading variable 1, so I can actually interchange these variables here. That's row 1 and row 2. I can interchange if I want, or I can as well leave it this way and do my row reduction. So let's go ahead and leave it this way, since this is just going to eliminate. So our row 1 will remain the same. Okay, and then row 2, this plus this, we can just use for row 2, we can just use row 2 plus row 1 to eliminate this. That's actually our intent. So this will turn to 0, this plus this will become minus 1, and this plus this will also turn to 0, and that's beautiful. So while here, if you do this plus this, it will not eliminate. So what you will do is to look for constants to multiply. So you multiply with their coefficients, or sorry, with their values here. So if I do something like watch this, 2 times row 3, remember I'm replacing row 3, then plus 3 times row 1. Remember your leading variable will be your minus 2, okay, or leading coefficient. Okay, so I'm doing everything with respect to row 1. So I'm using row 1 to eliminate these 2 now, and this one. I've achieved the elimination of this, so I need to act on this now. And to do this, I'll just look for what I will multiply with this and multiply with this, so that their values will be the same and I can eliminate. And I've used 2 to multiply this, which will give me 6, and then I'll use 3 to multiply this, which will give me minus 6. So if you add them, you definitely get 0. So we have 0 here, and then here we multiply with 3. Sorry, we'll multiply this one with 3 and multiply this one with we'll multiply this with 2. The first one by 2, and the second one by 3. Remember, we are adding, so this is going to become 3, right? And so you are going to get 5 here, and finally on the last one, you are going to multiply this by 2, which is minus 6. Okay, then multiply this by 3, which is 6 itself. If you add, you will also get 0 here. Okay, so what will that give us? Okay, so from here we are now going to have okay, so we can eliminate this other 0 here. Remember, okay, yeah, remember we can now use this as the leading variable to eliminate this. And in doing that, we are now going to get another system. Row 1 will be the same, row 2 will also be the same, but you can choose to multiply row 2 by minus 1 so that it will be positive, but you can still leave it this way. Okay, so and that's going to be, so I'm now going to use it to eliminate this, and to eliminate this, all I'll need to do is row 3 plus 5 times row 2. My row 2 is now my pivot point. Okay, so now if I do that, this is my row 3 plus 5 times that row 2 will be minus 1, and that's going to give me 0. So I already have 0 0 here, and then in this case everything here will of course turn to 0, so because they are all zeros. All right, and that's what I will obtain as the reduced form of my matrix. Okay, so then immediately you see that equation 3 is gone. So immediately that happens, you can now bring back our x. How do you do that? So you can now have our minus 2 1 2, then we have 0 minus 1 0. You don't need to bring all the zeros because they will still turn to 0, and then you just have x1 x2 and x3 all equal to 0 0 0. Okay, so at this point I can now expand and bring out my equations. So this multiplying here will give me minus 2x1 plus x2 plus 2x3 is equal to 0. That's equation 1. And equation 2 is going to be 0 times this is 0. This times this is minus x2, and then plus this is also 0. So this is going to be equal to 0. So x2, so what it means is that my x2 is equal to 0. Okay? And then if x2 is 0, you can now substitute here to now get your x1 and x3. So that means I will have minus 2x1. This will go away. So I will just have plus 2x3 is equal to 0. So the implication is that x3 is a free variable. So I can give it a name. I can say let my x3 be equal to t. So if I call my x3 t, so the implication is that, okay, I can finish that up here. Okay, so what it means is that my x1 will now be, remember it is minus 2x1, then plus 2t now is equal to 0. Divide through by minus 2, you get that x1 minus t is equal to 0. Therefore, my x1 is also equal to t. Alright, this is beautiful. So what it means then, remember what we are looking for is the value of x. That's what they told us here. Solve for x. Let me bring it down. Yeah, solve for x. Okay, so, and we have gotten all our x, which are x1, x2, x3. So what it means is therefore, let me use therefore instead of this implies. So therefore, my x, which is equal to x1, x2, and x3 is equal to, okay, what is x1? x1 is t. What is x2? x2 is 0. What is x3? x3 is t. And you can write that in a factorized form where you will have that this is equal to 1, 0, 1, all multiplied by t, where t is a real number. Okay, so that means my t can be any number. If you pick any t here and substitute, let's say 1 as your t, so you have 1, 0, 1 as your x. If you put it there, you see that you are going to get 0, 0, 0 when you multiply it by a. So that means a times x is equal to 4t. Sorry, 4x. You are not going to get 0, 0. You will get 4, 0, 0, 0, 4, 0, and so on and so forth. Okay, so that's exactly what we are asked to get. So this is the value of our x. Okay, so we have our x value. All right, now let's go ahead. So, and that is the end. Oh wow, okay, question 5 only has b, a and b. Okay, so that is the end of module 2. Wow, beautiful. We are done with module 2. Okay, so next is to go to module 3, and that will be in another section. All right, so this is where we end it for this particular section, and we will continue from there in our next video. All right, so this is for question 5. You go over here, you will find question 4. You will find question 4 here. Okay, so you can increase this, okay, to help visibility. Okay, so this was where we started today. So, and then we got over to here. All right, so we end it here for this video, and see you in the next video. Bye.